What we were looking at today in class was if you were given a certain set of numbers that have a clear pattern, can you find the equation to that pattern? So in all these cases, I'm given the first 5 numbers, but if I wanted to know what number 50 looked like at the end of the pattern without having to write it all out, I could find it. To do this, I need to understand what the equation is. The equation is going to have 2 parts. First part is going to be your variable, so that's in green here. This is the part that jumps every time. In this case, when we look at the table, it's jumping up by 3s. So I know no matter what, it's going up by 3 each time. However, if I look at the first part of my table, it didn't start at 3. So when I put 1 into 3x, or 3 times 1, I didn't get 1 as the answer. This means something else had to be there or been taken away before then. This ended up being my constant, so the thing that I started with. Some people refer to the constant as the 0 value. So if I went back a step, what did I begin with before I started adding 3's? In this case, if I took away 3 from 1, I would have gotten -2. That could be considered one way to find the constant. Another way to find the constant could have been to look at the variable, which is 3, and the knowledge that I know what it equals at certain times in my y values. So for example, when x is 2, it has to equal 4. So if I were to plug into my equation, when 3 is multiplied by 2 plus a constant that I'm not sure of, I know it has to equal 4. Then I just do some simple algebra. 3 times 2 is 6, plus something equals 4. The something I'm adding in this case is the constant, which is -2. Once I know what my constant is and what I'm jumping up by each time, I'm going to be able to find my equation. So in this case, 3x minus 2. You can double check this by plugging in another number into your x value. For example, if you were to plug in the 3, multiplying it by 3, then subtracting your 2, does it give you the 7 that you need? Looking back at our first page, we can do the same thing. Here, we notice that it's jumping up by 3's. The fact that it's jumping up by 3's tells us that our variable is 3x. However, at this time, we still don't know the constant. What we do know is the fact that the first term was 7, the second one was 10, the third was 13, and so on. So if I were to plug in 3 when x is 1 plus something I don't know equals 7, I can then use algebra. I use c to represent the constant to figure out what that missing variable is. So c, 3 plus what gives me 7, c has to equal 4. Because I already knew what it was jumping by, I knew my variable, now I know my constant, I put it together to give me an equation of 3x plus 4.